Hello everyone. Good evening all of you. Very good evening, my dear. Hope I am audible. Hope I am audible, my dear. Shall I start the session? Shall I start the session? Am I clearly audible, everyone? Just please let me know in the chat box. I am clearly audible. Hello guys. Shall we start this session? Yesterday I have discussed this problem. See, I have given you this problem, but unfortunately I don't know, my voice was not coming properly. I have given this problem. I'm going to explain you because we don't have enough time. A link OB is rotating with a constant angular velocity 2 radian per second in a counterclockwise direction, and the block is sliding radially outward on it. You can see here in this picture that this is the link. This is the link OB. You can write like this. This is a link OB, and this link OB is rotating with a constant angular velocity omega. Okay, in a counterclockwise direction, and a block is also sliding in the radially outward direction with a uniform velocity of 0.75 meter, 0.75 meter with respect to the rod. Here OA, the radius is given to you is 1 meter. What is the question? The magnitude of the absolute acceleration of the block. What is asked, my dear? Absolute acceleration. So what is absolute acceleration? The meaning is net acceleration. So here you can see whenever a block is sliding on a rotating bar, we can observe one acceleration that is called your Coriolis acceleration. It's called your Coriolis acceleration. So since the direction of Coriolis acceleration in this direction, that is your 2 v omega. So we have calculated that is your 3 meter per second square. And the centripetal acceleration, my dear, in this direction, centripetal acceleration, that is omega square r. Okay, so omega is your, my dear, omega, you can see omega is your 2, and the radius here it is given, radius given is your OA is your 1. Okay, so here it is 4. So it is 3, it is 4. So whenever you find out the resultant acceleration, that is called your absolute acceleration. It is root under Coriolis acceleration plus centripetal acceleration. The right answer is your 5 meter per second square. I hope this part is clear. Everyone, please let me know in the chat box. Yes, sir. Whenever it is asked to find out the absolute acceleration, we can easily find it out. Right? So always take care of the word in the problem, whether they ask you to find out absolute acceleration or Coriolis acceleration. This is important. See, please note down this part, and then I'm going to discuss the other part, other topic today. Next topic. Find it out, everyone. Once done, let me know. Okay, would you like to note down the question? Please note down. Then I'm going to discuss the very, very important topic. Done, my dear? Once done, let me know in the chat box. That is done, sir. Clear, everyone? So now I'm going to discuss the next topic. Today's topic, see. See, my dear. Please share the chat of the students. Please share chat. Please share chat, my dear. See, my dear. No, sir means no, sir. What is no, sir? There is no reply from the students. Okay, there is no. Are students watching this session? How many students are there? Okay, everyone, now see. Kinematics, see. Okay, okay, everyone, let's see the new topic. Kinematics analysis of single slider crank mechanism. Important topic it is, my dear. Very, very important. So today I'm going to end this topic, right? If it will take 3 hours, I'm going to end it. 2 hours, I'm going to end it, right? So most probably 2 hours and some minutes, 30 minutes is required to end this topic. So everyone see carefully. Kinematics. So what is that here? Suppose, my dear, this is your this is a center. right? This is your this is the slider, right? See everyone, right? So here is your connecting rod. Okay, this is the crank. So this is the diagram. See this diagram carefully. So here, guys, what I could say, this is your crank. This is your connecting rod. Right. And now, my dear, this is called your, suppose when the crank is here at this point, the piston will be here in this position, right? And it is going to move. It is called your top dead center. This is called your bottom dead center, right? So from top dead center, this point is called your TDC. When the and suppose initially the piston is here at this location. So this is the point. And whenever crank rotates certain angle, suppose crank is going to rotate certain angle like this. This is the angle theta, right? Crank is going to rotate this angle theta, everyone. See. Theta. Now see, this is the theta, and this is the length. This is the length, my dear. This is the length is L, and this is your radius R, correct? And this angle we are assuming as beta. This angle we are assuming as beta. This angle we are assuming as beta, correct? So now, my dear, this is the displacement, you can say, when it is going to displace by X amount. Right, X. And this is called your piston. So now, my dear, what I'm going to write here, some points. This angle is your theta. This angle is your beta. Beta is the angle between the connecting rod and the line joining the center and the piston. And R is the radius of the crank. Theta is the angle between this line joining and the crank. And suppose I'm going to draw a perpendicular here like this, everyone. Right. So this is called your, this is the perpendicular, and you can just name it like this, my dear. You can just name it, suppose this is called your A, this is called your B, this is called your C, this is called your D. Okay. Now M is the mass of the reciprocating part. Reciprocating part means piston. And R is the radius of the crank. L is the length of the connecting rod. L is the length of the connecting rod. Therefore, N is equals to what we can write. We define actually N is the ratio. It is the ratio between L by R. Correct, everyone? And remember that L is greater than R. The length of the connecting rod is very greater than the radius of the crank. Okay, now theta is the angle rotated by the crank. From TDC, from top dead center, the angle rotated by the crank, that is your theta. Omega is the angular velocity. Angular velocity of the crank. Omega is the angular velocity of the crank. Now, in triangle ABD, suppose in triangle ABD, if I am talking about ABD, what is sine beta? You can say sine beta is equals to AD by AB. AD by AB. AD is, my dear, AD by L. AD is equals to L sine beta. Correct. Now, in triangle ADC, in triangle ADC, you can write sine theta is equals to, in triangle ADC, sine theta is equals to AD by R, correct? AD by R. AD by AC. AC is R. So sine theta is equals to, so AD is equals to R sine theta. Correct. So both AD are equal. L sine beta is equals to R sine theta. We can say that. And we have also know that L by R beta is equals to sine theta. So here you can write N sine beta is equals to sine theta. Correct, my dear? Now tell me. So here sine beta is equals to sine theta by N. Very important result it is, my dear. Very important result. Here sine beta is equals to sine theta by N. Clear? So this is the very important discussions you must remember. So I hope you guys are noting it down. So please note down. Please note down all the discussions. Starting from here, note down all of you. Once done, let me know. Note down this part, everyone. Done. Okay, okay, very good. Please note down. Clear, guys? Okay, very good, very good, great. Cookie Isha is saying, sir, done. Okay. Cookie Isha, now I am going to now I am proceeding to the next part. I'm giving other students time so that they can also note it down. Other students, please write your name in the chat box so that we can talk to each other and uh, so that I can come to know that what is your query. If you have any trouble in the understanding of this topic, so I'll make it more easier for you to understand. Tell me, tell me. Now see everyone, the important result in this, that is, see, I hope everyone has note down. See, now my dear, some results are very important here. So I'm not going to derive that results. I'm going to write it. Okay. So for piston, everyone see the displacement of the piston when this crank is rotated by theta angle, then what will be the displacement of the piston, the expression of x, right? So here some results are there. So please note down all the results which I'm going to write. So here first result is here, my dear. X is equals to R 1 minus cos theta plus n minus root under n square minus sin square theta. Right. This is the first expression. N is your L by R. That is expression of displacement. But it is not asked. Frequently, we ask this velocity, the velocity of the piston expression. It is your omega R. Whenever you differentiate, na, you are going to get this. Omega R sin theta plus sin 2 theta divided by 2n. Then your acceleration, omega square R cos theta plus cos 2 theta divided by n. Correct, my dear? So this is the very, very important relation. Right. This you can also calculate as dx by dt. Whenever you differentiate, you are going to get the velocity of the piston. And this is your dv by dt. Well, whenever you differentiate velocity, you are going to get acceleration. Right. This is the important result for piston. Now for connecting rod also we have some formulas. That omega of the connecting rod is omega cos theta by n alpha CR is minus omega square sin theta by n. Right, because whenever you integrate, na, I'm showing you one example. Suppose you are going to differentiate it. It will be your omega, the differentiation of sin theta is cos theta, and this is going to be your cos 2 theta into 2. So 2 is going to be cancelled. So you are going to get this result, right? And again, the last differentiation, the d theta by dt is going to be your omega. So here it comes omega square, because this omega and d theta by dt is your omega. So this is how you can get. I'm showing you some derivation. I can show you, no problem. But actually, the result is important. See, this is for my dear. This for my dear connecting rod. Right, connecting rod. So this you can find out by d omega by dt. Omega of the connecting rod by dt. Correct, everyone? So it's quite simple. One, I can show you one. If you are going to calculate, suppose d omega, you are going to calculate this. So omega is your same, and cos theta differentiation is minus sin theta by n, and again d theta by dt. D by dt is omega. It will be your omega square. It will be your omega square, my dear, minus omega square sin theta by n. Right. So this is how you can get it. So I would suggest you to remember only the expression of what? Only the expression of velocity. You just remember, and acceleration you can easily find out. By differentiating this, by differentiating the velocity, you can get the acceleration. In a similar fashion, you can do the differentiation of velocity, you will get it. Now, guys, I'm going to show you some problems based on these two results, in which we have to find out velocity as well as acceleration. See, because once we practice more, we will have more clarity. See everyone, this is a problem. A slider crank mechanism with crank radius 50 mm and connecting rod length the crank is rotating with uniform angular speed. Ten radian per second counterclockwise direction. What is the speed and acceleration of the slider? Clear, everyone? See, it is given like this, everyone. Right. This is your 50 mm. This is your 250 mm. This is your 255 mm, correct? No, sorry. This is going to be your like this. This is your omega. This is the crank. This is your given. This is the diagram, right? And it is moving with omega here in this direction. Piston is moving in this direction. Velocity of the piston, right? So can anyone find it out? Can anyone tell me both the values, the velocity as well as acceleration of the slider? This is the piston. Piston slider means same, right? This is the slider as well as piston. Tell me what is the velocity? Both is asked in this problem. Here, this you know very well that this part is your. This smaller part is your. This smaller part is your radius. This is your length of the connecting rod. Whenever sometimes you get confused, so always the smaller value is the radius, and this is your length of the connecting rod. So here you can say, my dear, that R is your 50 mm, L is your 250 mm. So N is equals to your L by R. So here N is equals to So where what we can say n is equals to 5. So guys, everyone solve this. Please solve, my dear. This is very, very important. Very, very important. You need to find out everything. Parthamesh, hi, how are you? How are you, Parthamesh? Hope you are doing good. Parthamesh, can you tell me the right answer for this? Everyone, I'm giving you time. You please try yourself, right? Once you try yourself, it will be more beneficial. See, find out. How can we get the theta and all? Because without theta, we cannot find it. So see, always remember the theta is the angle between what? Theta is the angle between, my dear. That is this is the crank as well as this is the velocity direction of the piston, right? This is the horizontal line. So crank and this is going to be your theta. So you can easily write smaller is your crank. So this is going to be your theta, my dear, and this is going to be your beta, my dear, right? But beta is not important. So now you can draw the perpendicular here in this. It is going to be like this. It is going to be like this, everyone. Clear? See. Find out, everyone. Very good. Find out, everyone. Clear, anyone? Tell me the right answer for this. Parthamesh and Cookie Isha, both of you are still not getting the right answer. Please find it out. No one is giving the answer. So now let me start this session. See. Anyone, anyone, anyone? Now let me start, everyone. See. No one reply. Okay, so now let's start. I think no one able to solve this problem. It's okay, no problem. See, everyone. See, how can we solve this? It's quite easy. First of all, we need to find out this, everyone. This angle is 90 degree, it is given. Right. Actually, I missed to write this. That's why maybe some of you are not be able to. This angle is 90 degree, correct? Now everyone tell me, if it is 90 degree, we can apply the Pythagoras in this. This suppose A, this is the B, this is the C. Then we can write AC is equals to AC is equals to AB square BC square. 50 square plus 250 square. Therefore, AC we have what AC, my dear? Actually, I missed my calculator. So it will be 1 minute. Let me take it. It is going to be your 50 square plus 250 square root answer. 242. This is your AC, right? Now see everyone, once we got the AC, in that case, we have to find out theta. Without theta, we cannot do anything. So it is quite simple. You can do one thing. Suppose in this triangle, if I'm going to use, because it is a right angle triangle. So here you can write that sine theta is equals to perpendicular. This is the perpendicular, this is the hypotenuse, means 250 divided by 255. Theta is what? Are you guys getting the voice of some sound? Right. 78.63 degree. 78 point. Right. Once we got theta, now we have to find out the velocity as well as acceleration. So it will become quite easy for us to find out. V is equals to omega r. Sine theta, sine 2 theta divided by 2. Correct. That is quite simple. So V is equals to omega is what? How can we find out omega? Omega is given to us. That is your 10 radian per second. Omega is your 10 radian per second. R is your radius is your 50 mm. Means 50. Sine into 2. 157.27 divided by, what is the value of n here, my dear? N value is 5. Once you solve, you are going to get the answer. See. So what is the velocity? What is the value of velocity, everyone? Tell me, guys, what is the velocity we are getting here? Please, anyone? Can anyone tell me what we are getting? Cross check this, please. This we are getting 0.509. Correct, everyone? 0.509 meter per. Is that clear or not? Is that clear or not, everyone? You guys are not participating. You guys are not participating. Why? Now tell me the acceleration. What is the acceleration? Omega square r cos theta plus cos 2 theta by n. Omega square r. The value of omega is 10, means it is your 100. 50 into 10 to the power minus 3. N is your 5. Tell me what is the right answer here? Plus cos 78.63. This we are getting 78 point what we are getting, everyone? 0.063, correct. 0.063 that we are getting. 0.063. Absolutely right. This we are getting, my dear. Correct, very good. Now the next thing, this was asked, so you have calculated. Now suppose in this problem I am also going to add it, that find out the omega of the connecting rod as well as angular acceleration of the connecting rod. So you know that omega of the connecting rod is equals to omega cos theta divided by n, right? Omega we have, my dear, omega is what? Omega we have, that is your 10 cos 78.63 divided by n. N is your 5. So this we are getting, my dear, 0.394, that is 0.394 radian per second. Now alpha of the connecting rod is minus omega square. Differentiate this, sine theta by n. So minus 100 sine 78.63. N is your 5. So sine 78.63 into 100 divided by 5. 19.6. Correct. This is the answer, everyone. So please note down all this mathematics. That was very, very important. Okay. Then I'm going to discuss the next part. Next problem, actually, I'm going to give you. Absolutely right. Absolutely right. I am unable to get the expression of sine theta. Srivastav is saying, we do not know the perpendicular length nor the base height. Okay. See, my dear, actually here in this problem, when it is 90 degree, so this is the theta. So in that case is your L, this is your R. So this is going to be your perpendicular, this is going to be your base, and this is going to be your hypotenuse, right? So for sine theta, this perpendicular by this hypotenuse, right? And hypotenuse we have already calculated with the Pythagoras, right? So by Pythagoras we have calculated it is 255. I hope this is clear, right? Srivastav, Prathamesh, please let me know your doubt is resolved or not. Your doubt is resolved or not. Done, my dear? Done or not? I hope this part is done. Now, guys, see the next problem. Done, very good. Now, see the next problem, everyone. The next problem is, my dear, See, my dear, we have some problems. Firstly, I just wanted to do this one. Do this, my dear. Today, I'm not going to waste time. Just firstly, I'm going to do the problems. Quite beautiful problem. Consider the triangular formed by the connecting rod and the crank of an IC engine as the two sides of the triangle. If the maximum area of the triangle occur when the crank is 75 degree, when the crank is 75 degree, means this 75 degree with the top dead center. The ratio of the connecting rod length to the crank radius means L by R, means they ask you N. What is the value of N in this, everyone? What is the value of N in this? Tell me. Can anyone find out? This is the one problem. And the second problem that we have, these are the two problems which I'm going to give you. Everyone, please solve both the problems, this one as well as this one. Okay? So try it. And I'm going to charge my pencil for that period of time. So both the problems, everyone try. The speed of the slider is asked in the question number 2. So both please try to solve. Okay? Okay, I'm giving you 5 minutes for both. 3 minutes for question number 1 and 3 minutes for question number 2. Okay, everyone, try to do it. Try this, everyone. Very beautiful problem. 3-4 more problems I'm going to do it today. Hello. Prathamesh is saying, sir, 0.509. That is wrong answer, Prathamesh. Wrong answer. 0.509 is not present in the option. It is not in the option. How can you give this kind of answer? How can you give this kind of answer? That is absolutely wrong. See, I'm telling you, how can you solve the problem number one? See, quite easy. Problem number one is quite easy, my dear. See, then you need to try the problem number two. Okay, see, what is that? Here, see here, in this case, what we can say that, suppose, right, this is your piston, right? So here you can say that this angle is going to be your theta. This angle is going to be your theta. This is your R, this is your L, right? This is your beta. So here what is given? Consider a triangular formed between the connecting rod and crank. This is a triangle, this triangle, the triangle formed, right? If the maximum area of the triangle occurs when the crank is at 75 degree, means when it is at 75 degree, when the theta is given to you 75 degree, this is going to be your 75 degree, right? So always remember, we write, you know very well that area of this triangle. How can we write the area of this triangle? That's quite easy. See, area of this triangle is equals to 1 by 2. Suppose you name it A, B, and C. 1 by 2 AB into BC into sine theta. Sine theta phi, whatever you want to say. Suppose I'm writing it as a phi. Phi is the angle between AB and BC. So how can you say it is going to be maximum? This area is going to be maximum. How? It reaches maximum value only when the phi is tending to 90 degree. When phi is 90 degree, then in that case area is equals to 1 by 2. AB is your L, this is R into sine 90. Sine 90 is 1, right? Because the maximum value, sine maximum value, you will get at 90. Means the area is your 1 by 2 L into R. Okay? See, now in this case, when this angle is going to be your 90 degree, this is your theta is given to you. So guys, automatically when this angle you got 90 degree for maximum area, So actually, we don't have to find out this area. In the problem, they don't ask you to find out area. They ask you to find out the value of n, small n, right? The ratio. So a small n we can easily find out, but is L by R. And L by R, how can we find out? So in triangle, it's very large font size. In triangle, ABC, tan 40, tan 45 is equals to tan 75, sorry. Sometimes it really gives me trouble. Tan, what is that? Tan 75 is equals to L by R. So tan 75, actually, I don't know what is the value of tan 75. Tan 75, we need to find out. So tan 75 and L by R is your n. 2 plus root 3 it is. 2 plus root 3. That is the value of n is your 3.73. Correct? Going to be the right answer. N. So here C is the right answer. I hope this explanation is clear, everyone. So please note down this, and then after that, everyone solve this problem. This part is done, everyone. Now I'm going to give you this. Please find out this. Again, I'm going to give you 5 minutes, everyone. Please try. Okay, please try this. Anyone? Anyone tell me the answer, please? Prathamesh answer is wrong. Prathamesh answer is wrong. That's quite simple problem, but let me tell you this. See. We can solve it by two different methods. Method number one. Slider crank mechanism with crank radius is 60 and it is your 240 is the connecting rod, is the piston. No problem at all. Angle is 90 degree also. Right. So here what we can say, omega is given to you. First of all, we know this angle is going to be, this angle is going to be your beta and this angle is going to be your theta. Correct? So we have this result, my dear. See everyone, we have this result. What is that result? See. We know that n sine beta is equals to sine theta. N sine beta is equals to sine theta. Theta is the angle with the crank and beta is the angle with the connecting rod. Okay. So here you can see. So crank angle is theta and here beta. So we can directly use here, everyone, that n sine beta is equals to sine theta. Correct? Now, n sine beta, what we can write? Here we can write that beta is nothing but 90 minus theta. Beta is nothing but 90 minus theta, correct? Correct, everyone? Because the sum of the total angle is 180. So here it will be theta plus 90 plus 180. Sorry, plus beta is equals to 180. This is going to be your 90 minus theta, correct? So now beta is your 90 minus theta is equals to sine theta. So here n cos theta is equals to sine theta. N is equals to tan theta. Therefore, theta is equals to tan inverse n. So here what we can say, tan inverse L by R. So here theta is equals to tan inverse L is your 240 divided by 60. Okay. So here theta is equals to tan inverse 4. What we are getting, everyone? Tan inverse 4. 75.96 degree. See. Next is your, my dear, next is your V is equals to, velocity V is equals to omega R sine theta plus sine 2 theta by 2n. Now put the value, you will get the answer. I don't know why this silly question you guys are not be able to solve, which means your level is very poor, you guys. Very, very poor level, right? 10 radian omega is given and radius is your 60, correct? Radius is 60 mm. That is a 10, 60 into 10 to the power minus 3. Oh, sometimes it's very difficult to write on this iPad, right? Okay. Sine theta. Sine theta. Theta value we have 75.96. Oh. Plus sine of 75.96 into 2. 151.92 divided by 2 into n. N is your 4. What is the answer we are getting, everyone? It's a lengthy calculation, but you please tell me. Sine of answer divided by 8 plus sine of 75.96 into 10 into 60 into 10 to the power minus 3. This we are getting 0.6. Oh, V is equals to 0.617. Right, I hope this is clear. Meter per second. This is the final answer. Everyone done? This is how we can solve this, right? Note down, note down, note down. Note down, everyone. Now, everyone see, we can also solve this problem with a different method. And that second method will be more easier. How we can solve? By using the chapter number 2 equations. See, we know that, everyone, this is angle is 90 degree. So what you can write, we have to find out the piston velocity, right? The velocity of the piston. Okay. So here, see, this angle is 90 degree. So about this point, this will be the eye center. About this point, it will be in pure rotation. Because when this angle is 90 degree, so the velocity of the connecting rod, if we want to find out the velocity along this rod, V, right? So if we are assuming this as the eye center, you will get one tangential velocity in this direction. That velocity is equals to V is equals to omega r. So you will get a tangential velocity in this direction. Everyone remember this. Very, very important it is. See, my dear, if you are going to rotate it like this, So you are going to get a velocity, tangential velocity in this direction. Right, V. 90 degree it is given to you. This angle is your 90 degree, right? Because you are going to rotate it in this direction. Omega, clear. So this velocity will be what? V is equals to omega r you can apply, and this is going to be omega is your 10 radian per second, and radius is your 60. 10 radian per second, 10 60 mm, 60 into 10 to the power minus 3. This we are going to get 0.6 meter per second. Now, once you break this component, 0.6, you are getting the velocity in this direction. Now, once you break this component, see, the component of this velocity along the connecting rod in the direction of piston velocity, it is going to be your, suppose, this is your piston velocity, my dear. This is your VP, velocity along the piston. So once you break the component in this direction, right, in this direction as well as in this direction, so this velocity will be along the piston direction. See, because here in this direction is the V, so the V cos beta is equals to the velocity of the piston. So you can write directly here that the velocity of the piston is equivalent to V cos beta. V is equals to, sorry. 1 minute. What I see, if you are going to break the component, see, the piston is going to move in this direction with the VP velocity, and the component of this piston along this direction is equals to V. So you can also write VP is VP cos beta is velocity of the connecting rod. See, VP cos beta is equals to V. Okay, my dear. This I am going to write, because in this line we have the velocity and we have to find out the velocity in this direction. So here you can write that VP V is equals to VP cos beta. Clear? So we need to find out velocity of the piston. It is your V by cos beta, correct? V by cos beta. So here VP is equals to, V is your 0.6 divided by cos beta. Cos beta is your beta. Beta is 90 minus theta. So 90 minus 75.96, correct? So here VP is equals to, everyone, what we are getting? 0.6 by sine beta. Right, 90 minus theta means sine theta, you can say. Sine 90 minus theta, sine theta, cos 90 minus theta, sine theta. So VP is equals to 0.6. 0.6 divided by 75.96. Sine 75.96. 0.618 meter per second. So same answer we are getting, everyone. The answer which we got earlier, that is 0.716, 0.617, and here we are getting 0.618. Approximately the value is same. I hope this is clear. Clear, everyone? Okay, so always remember when you are going to break its component in this direction as well as perpendicular to this. So VP component in this direction will be equals to in this direction, my dear. and perpendicular to this direction, right? So here this is equals to your Vp cos beta, right? It is equivalent to V. So I hope this discussion is clear. Everyone, please let me know in the chat box. Sir, method number 2 is clear. Now we proceed to the next topic, next part of the discussion. Please, both the methods are clear. Both the methods are clear, everyone. Clear, everyone? Clear, everyone? Very good, very good. Now proceed to the next part. Next problem which I'm going to give you, everyone, see. Find out, everyone. Now, guys, I am expecting from everyone to solve this. See, everyone, please solve this. Maximum acceleration is asked. Maximum acceleration of the slider. So how can we get the maximum acceleration, anyone? Yes, absolutely. Right. Absolutely. We can get it. So I have done like that now. Theta 240 by 60. Yes. You find out this problem. Maximum acceleration, please find out. Quite easy problem it was. Unfortunately, no one is responding. See, how can we solve this, my dear? Acceleration is asked, maximum acceleration. Do you know the expression of acceleration? In this, we know very well. This is your omega square r cos theta plus cos 2 theta by n. So here, guys, we can say that length of the crank and connecting rod are equal. Means here L is equals to R. Here L is equals to R. Therefore, N is equals to L by R. It is equals to 1. Okay. Now the maximum. So how can we get maximum? We get maximum only when, suppose when you are going to use theta is equals to 0 degree, because the maximum value of cos you are going to get when theta is 0, and here also when theta is 0. in sine when the value is towards 90. Okay. So for theta is equals to, always remember, for theta is equals to 0 degree for maximum acceleration. Okay, so here what we can say, omega is your 14 square. Radius is, my dear, it is equal, that is 0.3 meter, correct? Cos 0 is 1 and cos 0 is 1, 1 by 1 means it is your 2. So it is going to be your 196 into 0.3 into 2. A is equals to what we are going to get, 196 into 0.3 into 2. This is your 117.6 meter per second square. Correct, everyone? This part is done. Very good. So now we are done. We have done so many problems, everyone. Okay, now we have to understand the dynamics analysis of C. So very important topic. Dynamics analysis of single slider crank mechanism. So earlier we have seen the kinematics analysis, which means in that we discussed the velocity, acceleration, and here we are going to discuss about the force, crank mechanism. Right, my dear. See, so I'm going to take a break of 5 minutes, everyone here. Then I'm going to start it again, right? 5 minute break. That's very quite easy, a simple break. Okay. Then I'm going to start it. Okay. Welcome back, everyone. Dynamics of Dynamics analysis of single slider crank mechanism. See, in this we are going to analyze the force. What is that? See, very important discussions. So please take care. This. See here, my dear. This is your basic diagram. Now we want to analyze the force. This angle we know very well. This angle is your theta. Now see. Theta, right? This angle is your beta. So here what we can say, in basic thermodynamics, we have seen that the chemical, right, combustion takes place, and here in IC engine, working fluid is there, and the working fluid due to combustion applies a force. This is right, applies a force on this. This is called your F. This is the F force applied by the gases present in the piston on the piston. Okay. Now, what is going to be happen? This is F force is applied, and there will be one force which is along the connecting rod. So you can say this is the force which is along the connecting rod. This is called your FC. Correct, my dear? Now, once you project this FC, it is going to be here like this. Okay. When you extend this, right, FC. And once you break the component of this force along the connecting rod, it is having two components, one in the vertical direction, one in the, my dear, vertical direction, and one in the horizontal direction. Right, so this is your FC cos beta. This is your FC sin beta. Correct, my dear? Now, since you know this is your crank, this is your crank, my dear. Crank. So here, see, this is a crank actually represents the radius. So there will be one force radially in this direction. Therefore, the one force radially in this direction, that is called your radial force. Remember that. And there will be one force in this direction. Right, everyone, remember that. This is called your tangential force. Right, this is a tangential force. Actually, this is tangential. This angle is actually 90 degrees, right? So now some students assumes that the forces along the connecting rod is actually at 90 degree with the radius. No, Tangential force is actually at the 90. This is the tangent, right? This is the tangent. This is just the extended part of the connecting rod. It is not necessary that the force along the connecting rod is equal to the tangential force. So make it very clear, everyone. Now see, my dear. I hope this is clear to you. So I am actually making it more in a different side so that it will be because I have to draw some angles. So remember that this will be your tangential force, right? When this is your tangential force, means this angle is going to be your 90 degree. This angle is your 90 degree, my dear. So now see what I'm going to do here. I am going to just draw a line parallel to this. A line parallel to this I am going to draw. See, so here what we can say, everyone, this angle is your beta, this is your parallel line, this is again line, right? So here what we can say that this total angle is going to be your, see, so here this is the line, this is the extended line. So here you can say, sir, this angle is going to be your beta. Am I right or wrong? Please tell me. Am I right or wrong? Please tell me, everyone, if you have any problem. This angle is also going to be your beta. When this angle is going to be your beta, now tell me, this is your theta, this is your this is a line. This is your theta, right? So this is your theta, and this is a parallel line. So this line is going to be intersect this. So what we can say, my dear, this angle is going to be, this is your, these two angles are equal. So here we can write that this is your theta. Right. So this is again theta. This is your theta. This is your beta. Means this total angle is your theta plus beta. Correct, my dear. This total angle is your theta plus beta. This total angle is your theta plus beta. That is very important. So now once you break the component, suppose you know the forces along the connecting rod. So once you break this component of this along the tangential direction and along the radial direction, okay, so you are going to get the expression of the forces. So now guys, I'm going to write all the forces and their formula because it is very, very important. One by one, let's understand. The first is your force along the connecting rod. Force along the connecting rod. Suppose force along the connecting rod is FC. This is a force along the connecting rod. So you can see that its component in the horizontal direction is FC cos beta. So from this equation, the force applied by the gases present, is nothing, is equals to FC cos beta is equals to F, the force by the combustion force, you can say that. So here, if you want to find out FC, force along the connecting rod, it will be F divided by cos beta. Right? F divided by cos beta. This is very, very important. If you want to find out in the problem, in gate problem, they are going to ask you, please find out the force along the connecting rod, so you can use this. Okay, remember that. Where F is the combustion force. Where F is the combustion force. Force applied by the gases on the piston. Combustion force or force applied by the gases. by the gases on piston. Correct, my dear? This F is usually given in the numericals. Second, normal very difficult to write, my dear. I don't know. Very difficult to write on this iPad nowadays. I'm facing so much problem. Normal thrust. On the cylindrical wall. Right. So you see on the cylindrical wall, this is a cylinder. On this wall, the force is acting Fc sine beta, right? So the force on the wall, that is your Fc sine beta. And you know that Fc, the force along the connecting rod is F combustion force cos beta into sine beta. So here Fw is equals to F tan beta, correct? Very, very important. Now the next part is, my dear, third one. Radial thrust force. Radial thrust force to the crankshaft. Crankshaft means crank, right? The radial force which is acting, Fr. Fr is your Fr. So here you can see it is the component of this. This is a force along the connecting rod, and its component in this direction is Fr is your Fc cos theta plus beta. Fc cos theta plus beta. It is your Fc cos theta plus beta. Fc is your, my dear, Fc is your F by cos beta. Cos theta plus beta, right? It is your F plus beta divided by. So because this is the force which is always given in the problem. That's why I'm giving you this force, right? Fourth, the tangential force acting on the crank. Force acting रुला देगा, ये लिखने नहीं देगा आज मुझे. Acting on the very difficult to write today. Very, very difficult, my dear. Tangential force acting on the crank. Unfortunately, it is not working now. Now it is Sir, can we solve some same problems using Coriolis? Coriolis, Coriolis is there when slotted bar is there, my dear. Kokisha, whenever the slotted bar and in that a slider is sliding, right? It is not that case. It is not that case. Okay, we cannot use that here. See, uh, tangential force acting on the very difficult, very difficult it is there. Tangential force acting oh, guys, now I'm going to end the today's session. I don't know what happened today. Okay, so guys, let's end the today's session here. See tomorrow. Radial force we have seen. Na? Radial force we have seen. Now we have to find out the thrust force. And due to this thrust, we want to find out a torque because the radius and the tangential force always causes a torque. Right. And why does torque this crank is rotating? This topic you'll see tomorrow. Thank you for joining me, everyone. Thank you. I hope you all have noted down this. Thank you. Bye, everyone. Bye.
Record